Hi there and welcome to the screencast. Tonight or this afternoon I'm going to be doing a little review of data types and the rules of indentation and hex decimal binary conversions, which will all be on tomorrow's quiz. Okay, so the first thing I'm going to do is declare some variables. Um, so the data types that we've introduced and that you need to know for the AP Computer Science exam are double variables, which are decimal values in between plus or minus 1 to the 308th power. Also, um, int values, which int values are between 2.8 billion and negative 2.8 billion. Then we have Boolean variables, or the Boolean data type, which are variables that is a data type that includes one of two values, either true or false. The last one are strings, which are a series of characters. So to declare a variable, I first give the name of the data type, and then I give the variable a name. So here I'm creating a double variable d, an int variable named I, and a string variable named s. All right, so that is declaring a variable. You have to declare a variable before you can reference it anywhere else in code. Now you can also initialize it at the same time by after the name of the name, you put equals, and then you put a value that is appropriate to whatever data type the variable is. Oops, and I misspelled true. Okay, string, yes, equals. Okay, so there's an example of me declaring and initializing four variables. And you can also declare multiple variables in a single line of code. So there I just created three double variables, r, t, and y. And literal values. So literal values are actual values. They are literally values that are assigned to variables. So in the first case, the literal value is 6.78. The literal value here is 5. The literal value here is true. And the literal value here is hello. Okay, also final variables. So if I put the word final before I declare a variable, let's see, then I'm creating a variable that can only be given a single value throughout a program. Okay, it can never be assigned another value. And the convention for naming final variables is you use all capital letters for the name of the variable, whereas if I have a regular variable, and if I make it more than one, the name more than one letter, I use camel case, which is lowercase first letter, uppercase letters for consecutive words, any words that appear in the variable. Okay, assignment statements. So assignment statements are where in your code you assign a value to a variable. So here I declared my variable. I'm going to assign it a new value of 8.56. So an assignment statement has an equal sign. On the right it has some expression or literal value, and what happens is whatever that value or expression, the value of that expression is, it gets assigned to the variable that is on the left side of the equation. Okay, now there are some operators that are used to increment variables by values. So they are plus equals, uh, minus equals, divide equals, times equal, and percent equal for modulus division. So when I have d plus equals 5.6, what's going on there is it adds 5.6 to whatever d was before, and that's the new value of d. It's just shorthand for saying this: d equals d plus 5.6. It only saves a few characters, but it is a little shortcut that saves, well, maybe it only saves one character um, in your code, but programmers do use it. So like d divide equals 4 would divide d by whatever by 4, and whatever that value is, it will assign it back to d. All right, so now you may be wondering, or hopefully you know, that even though d is an a double variable, whenever Java sees just an integer value with no point anything after it, a literal value, it understands that value to be an int value. Now, it is okay to assign int values to double variables. That int value will be automatically promoted to being its equivalent double value of 4.0. All right. On the other hand, it is not okay to assign a double value to an int variable. So I can't say I divide equals 7.8, and I will get a syntax error. All right. You cannot, Java will not automatically convert a double value to an int value. You can do what is called casting. So you can cast a double value to being an int value, and the way you do that is you, in parentheses, you put int, and then right before the value that you're casting, the int goes, and then what happens is Java just truncates the all of the decimal portion of the value. So, and it doesn't round, it just chops off anything past the decimal. So that this statement right here would be essentially assigning 7 to the variable I. All right, let's see, the next thing. What is modulus division? Okay, modulus division is regular integer division, except that instead of the remainder being, or instead of the answer to the division problem being the quotient, the answer is the remainder of the division problem. So if I said I equals, 54% 10, that's going to give me 4. Because if I do 54, I divide it by 10, it goes in 5 times, and the remainder is 4. Okay, let's see, what else do we have? Oh yes, I forgot, I plus plus means add 1 to I, and I minus minus means subtract 1 from I. Okay, now you can do operations in Java that contain both double and int values. So if I say this, if I say d equals, 4 times 3 divided by 2.5 plus, 7. So what's going to go on there? Well, it's going to do the order of operations. And by the way, modulus division has the same precedence as multiplication and division. So I'm going to do, the compiler is going to say, okay, 4 times 3, that gives me 12. 12 divided by 2.5. Well, 12 divided by 2.5, I have an int value and I have a double value. Oh, that must mean, according to Java, when you do an operation with an int literal and a double value, it automatically converts the int into a double, and it does the arithmetic based on the fact that this is really 12.0, and it will give you the answer that you expect. And let me see if I can open my calculator or a calculator. Yes, 12 divided by 2.5. Oops. 12 divided by 2.5 is going to give me 4.8. Then you're going to add 7 and you're going to get 11.8. On the other hand, if you did this, if you said d equals, 4 times 3, and then divided by, 5, okay, plus 7, well, Java's going to go ahead and say, all right, 4 times 3 is 12. 12 divided by 5 is 2, plus 7 is 9. And the reason that it's going to get 2 for 12 divided by 5 is if you divide two int values, you get another int value as your answer. And essentially anything after the decimal is chopped right off. So since 5 goes into 12 two times with a remainder of like 2/5 or 0.4, the 0.4 immediately gets chopped off. So that's the rule there. All right. Let's see, what else do we have? All right. Casting, or no, I did that. Concatenation of strings. All right, so the plus sign in Java means both addition, numeric addition, and it also means concatenation for string values, which means joining two strings together and creating one new string out of the two. All right, and Java makes a decision on what, if it's addition or concatenation based on what the two operands are. In other words, what literal values are on either side of the plus sign. As it goes through the expression one operation at a time using the rules of PEMDAS. So if I say string k equals, and I do 9 plus 3 plus yes, that essentially is going to assign a value of 12 yes to the variable k. Okay, so the reason it does is Java is going to go from left to right since we only have addition. 9 plus 3 is 12. That's the first thing it does. That's int division. I have an int value on either side of the plus sign, so it's int division, int addition. Then now it has 12 plus yes. So it says, oh, I guess I have 12 they must mean a string instead of the int value. And so it's going to treat the second plus sign as concatenation, and instead of well, it's going to make a new string out of 12. It's going to put 12 in quotation marks by default or automatically and give you 12 yes. Now this leads to a trick. So a way to quickly convert a number to a string is to say to concatenate an empty string to the values. So if I say k equals, 12 plus, all right, that immediately converts 12 into being this so that it can be used in other operations with strings. Now, converting from a string to a numeric value isn't quite as easy. We will get into that. It involves what are called the wrapper classes. It's actually not something that you need to be able to do for the AP Computer Science exam, but I probably will be showing it to you anyways. Okay, then also with strings are what are called escape sequences. So, and that means anytime you put a backslash n, okay, you know, that means a carriage return embedded within the string. So, what would be printed here if we printed out k? We would see this in the output. Um, so carriage return is embedded right in the string. Now backslash t means you're going to have a tab over to the next tab point embedded right in the string. So if we printed k, we would get, let's see, that. Okay, now notice, let's see, if I do, yes, let's say I want to do um, John slash T, no. So if I do John, um, well, never mind. I don't want to go over that because I'm not going to hold you to that level of detail. All right, so then the last thing you need to know to be able to do is to indent code correctly. All right, and the rule for indenting code is this. Um, it is whenever you have an open curly brace, it's the line before it is on at the same level of indentation as it. The line after it is one level inward. Um, okay, and then when you're done with that block of code, and what's inside a set of curly braces is called a block of code. Let's see. Oh, I know why. Let me use T. Didn't like the fact that I was declaring a variable more than once. And did I, let's see. Oh yeah, that's because I have this error here. It didn't fix it. And now what is going wrong here? Variable T is already defined in main method. Oh, yep, there it is. Okay, so that brings me to the point I may not have emphasized. You actually cannot declare a variable more than once in the same block of code. That's why I was getting that message, but we'll get into more of those details in just a little bit. Okay, so let's just to do the indentation again, let's look at something that it involves more than just one line of indentation, and that would be, let's see, there's a good example. Okay, so I have an open curly brace here. I indent one in, a closed curly brace, I indent one back out. Now you may say, oh, aren't these s.substring already indented inward? Technically they're not. It's all of these lines are part of a single statement. So those aren't new individual lines. They're all part of that if statement, and hence that open curly brace goes with the if statement, not these little lines of code that are right here. Okay, so then I have a closed one, I go back out, I have an else sign, I have an open one, I go in, I have another open one, I go in, I have a closed one, I come back out, then I continue onward at that same level. So that is the only thing you need to know about indentation of curly braces. All right, so now I'm going to take a little break for a second, and I'm going to do one or two. Come back. By the magic of screencasting, you won't have to wait long. I will be back and do a binary hexadecimal conversion or two to round out the. Okay, so now I'm going to review how to go between binary, hexadecimal, and decimal value. So the thing to know is that a binary value, its place values are the powers of 2. So an 8-bit binary number has a 2 to the zeros position, 2 to the first, 2 squareds, 2 to the third, fourth, fifth, sixth, and seventh, which are the ones, the twos, the fours, the eights, the 16s, the 32s, the 64s, and the 128s. All right, a hexadecimal number, on the other hand, has it's the powers of 16 instead. And the 10, 11, 12, 13, 14, and 15 digit for in base 16 are the letters A, B, C, D, and E. So this is going to be the 16 to the 0 power, the 16 to the 1, and the 16 squareds, and the 16 cubes. Which is the 1s, the 16s, the 256s, and then whatever 256 times, oops, I want to open that. Let's see, whatever 256 times, let's see, where are we? 16. So 256 times 16 gives you 4,096s. Okay, so in general, what I want to do, if you're going from binary to hexadecimal, you want to kind of use the decimal value as your intermediate step. So let's say I'm given the value 10110001, and I want to write that in hexadecimal. Well, I would first convert it to an integer or a decimal value. So when I'm going from binary to decimal, I write out the places, and whenever I have a 1 in that place, I add that value, that place value, to my running total. So in this first number here, I have a 128, I have a 32, I have a 16, I don't have any 8s, 4s, or 2s, and I have 1 1. So that's going to give me 177. All right, so now that's my decimal value. Now, what would that be in hexadecimal? Okay, well, let's see. You start with 177. You start on the left for your powers of 16. You say, okay, do I have any 4,096s in 177? No. So I would basically put a 0. Or I would just not have that position. Now let me move on to 256s. Are there any 256s in 177? No, there are not. So that means I don't have anything there. Are there any 16s in 177? Yes, there are. So I'm going to use my calculator to figure out how many. I could probably do it without, but I don't want to make a stupid mistake. Just thinking on the fly. So there are 11 16s. So what is the character 11 in hexadecimal? Well, that's the lowercase b. Okay, because A is 10. So that means I have 11 16s, and then let's see how many are left over. So I'm going to subtract 11 times 16 from 177. So let's see. So 11 times 16 is 176. That leaves me with 1 1. So, or that leaves me with 1. So I subtract out 176 and I get 1. Now, how many 1s are in 1? There's 1 1. So that means 177 is B1 in hexadecimal, and it's 10110001 in binary. All right, I'm sorry the screencast ended up so long. Usually they're not so long. You're probably wondering what the secret sentence is, the words in the secret sentence are. To be honest with you, I've been trying to make this pretty quickly, so I forgot to embed the words until this point. So I'm just going to flat out give it to you, and the secret sentence is going to be, the life you save may be your own. All right, I think that's from a Jack London short story that I read years ago. All right, so email me that. The life you save may be your own. All right, have a good night. Cheers.